All right, we are back, and the next step was how do we know that angle MNP, right here, this purple angle, and angle OPN, this angle here, how do we know that they are the same? Well, we know if MN and PO are parallel, then that those are alternate interior angles. Okay, so reason or evidence there, which brings us to, oh, I don't have it on here. What's the next one after this one? What's the next statement? Sorry, Sadie's getting us the next statement. Okay, so what's the final one? So the final claim or statement is that triangle. Read it off to me, Sadie. MQN is congruent to ORP. Okay, so what do we know? What do we have? We know that this angle's the same. We know that this angle's the same, and we know that this side is the same. So what I saw a lot of people putting in was angle, side, angle. This is wrong because we have an angle, or we have, if we start with our right angle, we have angle, and then the next thing we have is another angle, and then we have a side. So instead of being angle, side, angle, it is angle, angle, side. That's what we know for this one. Okay, that's your last piece of evidence. What's next? Oh, 8 is another proof. Yay, fun. Hold on just 1 second. All right, so we have line VW is parallel to YZ. That is a claim. Our evidence is it is obviously given. We have X is the midpoint of WY. This is the second piece that is given. If you look at the bottom, our last claim needs to be proving that WXV is congruent to YXZ. So we want to prove that WXV, this triangle, okay, is congruent. And I'm going to do these in different, I'm going to do the sides in different colors so we can see how the sides need to be. And then one more color, orange. Because they need to be congruent in exactly the same way. So that needs to be congruent. WXV needs to be congruent to YX. So this blue is here. YX. Yellow. So the yellows have to be the same, the blues have to be the same, and the oranges have to be the same because that's what it's saying. Does that make sense, you guys? Because it's the way it's written. It's written WXV and it's written YXZ. So the way it's written is how we have to prove they are the same. Okay, so what do we know? We have to take what we've been given and we have to extrapolate what we know from that. So if we know that two lines are parallel, we know we can use those angle relationships. So if we want to prove, can we prove that this angle where the orange and the blue lines connect is equal to this angle? Okay, and we can because if we call that angle ZYX, I know that's congruent to angle VWX. The ones I just made, and the reason or the evidence is because they are, anybody? Those two angles? These two that I just drew? Alternate interior angles, yeah. Okay, Now, here's an easy one too. I know I don't even have to be given to know that these angles are the same, and that is angle WX V is congruent to Y angle YXZ, and that reason is that they are vertical angles. And then this last piece, what's the other given that it gave me? It gave me the fact that X is the midpoint of WY. And you have to assume that everything they give you in a problem is going to come in handy. So if we know that X is the midpoint of WY, then I know that XY is congruent to WX. So WX is congruent to XY. And the reason I know that is by definition of a midpoint. By definition, it is the midway between W and Y. X is midway. Midway means both the sides have to be exactly the same. So this is by definition of midpoint. And then we have to look at what we got. We have two angles that are the same, and we have a side in between them that is the same. So if we go down and look at the final claim, which is to prove that triangle WXV is congruent to triangle YXZ, we know that is because of the angle, side, angle, triangle congruency theorem. Okay. All right, we're at 7 minutes. We're halfway through. Let's go on to the next one. If you guys are in the room, can keep track of that time for me. Okay, look, this is like exactly what we've been doing. What are we trying to find? What is the length of AD? What is the length of AD right here? Well, if we know that this is 30 degrees here, and this is 60 degrees, and this is 90 degrees, then this must be, 30 degrees. And this must be 60 degrees, and this must also be 90 degrees. And then I know that all of these, that 30 and 30 is 60, which makes this an equilateral triangle, and all sides are equal, which means AC is 12, so AD must be 6. Okay. All right, this was a tricky one, you guys. I hope I don't even get tangled up going over this on the video. Let's see, the triangle has a perimeter of 108 centimeters, right? And it wants us to solve for x. The problem is, since we have two x's here, right? Well, we have these x's, but we also have another variable here. Let's call this c because of Pythagorean theorem. What I know about this right triangle is that 9x squared plus 12, x squared is equal to c squared, right? So what I also know is the perimeter, so I know that 9x plus 12x plus c is equal to 108. Okay, I have two equations and two unknowns, so I'm going to use substitution to solve for this. What I'm going to do is, if I solve this up here for c, so if I just take the square root of this on both sides, c is equal to the square root of this side over here. So I'm going to have 9x plus 12x plus the square root of 9x squared plus 12x squared is equal to 108. And then what's 9 plus 12? 21? Is that right? Yeah. So 21x plus, actually, let's do this. Let's leave this side as 9x squared plus 12x squared equals 108 minus 21x. So if we square both sides, we get 9x squared plus 12x squared equals 108 minus 21x squared. Right? If we squared both sides. Then we need to square this, and we should be, 9x squared plus 12x squared, we can actually add those together. What is that? 21x squared. I think I missed a part in here that would have made this easier to solve. Do you guys see that anywhere? What? We did that. No, because we have an x. We don't know what this is. If x is 2, this is 18. Do you know that x is 2? Do you see what I'm saying? You don't know what that is? But I am wondering if I would have added these two together up here, if it would have made more sense, like 9x squared and 12x squared, I can make that. What's up, Ned? Oh, because you're multiplying it, because it's a Pythagorean triple? Are you sure it's a Pythagorean triple? Yeah, you are right. 3, 4, 5. This is a Pythagorean triple, so I'm glad I just gave you a lot of information to think of. I did it the long way when I did it, and it does work out. But what Ned said is that these are Pythagorean triples. So 9x and 12x, 9, 12, and 15 would be like it's a 3, 4, 5x. Then it does make it a lot easier to solve, because if you add all of those up, what's 15 and 9 and 12? So 36x is equal to 108. So if you divide both sides by 36. 3? 3. Good job. B. So Ned found a way to do it much faster than I did. Did you do it the same way, Sadie? Okay. Where are we on time? Oh, I'm going to stop this and do the next two on the next one.